Okay, we are going to take a look at skill 3. We're going to solve logs and exponential equations, including the change of base formula, which is you're going to have your calculator. So I know there's different versions, TI-83, TI-84, all of those will work, but you have to have a calculator that does logs, especially for this class and college algebra. So if you take a look here, for calculating log 1,000, and I'm going to show you my hi guys. I'm going to show you my calculator right here. So your log button, which I know I have circled on the paper, but it is right here. So that's log. Mine automatically opens up a parenthesis. So I'm going to type in 1,000. I'm going to close my parenthesis, and I'm going to go ahead and hit enter. And it gives me 3. So I'm just going through and solving each of these. So that's a 3. Make sure I use a different color. I like to change my daily color. So we're at 3. And then you're going to go through and kind of just do the rest of them. So again, you're going to find your log button on the left side. There's my log, 175, and hit enter. So it should look something like that. So that is about, so that means about approximately 2.24. So remember, the ones with the logs, remember the base there, that tiny little number that's not there is a 10, but you don't actually have to type that on your calculator. It automatically assumes that it's 10. So you're just going to go ahead and go through this. You can do it with me or on your own. I would suggest that you actually use your calculator and see if you can get the same answers as me. So we've got log 10,000, and that should give you 4. Natural log, which I'll also show you, is also located on the left side, ln, natural log. Notice how it's paired with e. So if you ever need to get to the e button, you just hit second e, and it says e to a power, so you have to put a power in there. If you just want e, you just do 1. So e is equal to, there's your value. But for us, we're doing natural log, so I'm going to type natural log. It opens up my parentheses for me, and I'm going to type 12, close my parentheses, and I'm going to hit enter. And that is going to go ahead and give me about 2.48. And I would go ahead and try to calculate the next one. So we've got natural log 125. Make sure you can type that. And that is about 4.83. And remember, the basis with the natural log is really e. Those are partners, right? But your calculator knows that when it does it. But what happens when you get log base 3 of 19? Some of the newer calculators can do that. When you go ahead and press your log button, you can see if it makes a small little box. I'm guessing most of yours cannot. So for that, when you have a base that is different than 10, you are going to have to do the change of base formula, which means you're going to take log base b of a, and this a here is going to go here, and then this b, your base, is going to go with this log, and it will calculate the answer for you. Or you can use a natural log, but typically I just stick with the log. So log base 3 of 19, notice again that 3, that small number, is the one that goes with the log on the bottom, and that 19 is the one that goes on the top. And when you type that in your calculator, log 19, close your parentheses, divided by log base 3, you should get 2.68. So it should look something like that. And notice how you do have to make sure you close your parentheses after the 19, okay? If yours opens parentheses like mine. So that is about 2.68. So notice that you can calculate any base, any log with any base number, because you can change it. And you can confirm that in your calculator. If you do 3 to the 2.68, it's about 19. It's off a little bit because, again, 2.68 wasn't the exact answer, but it gives you 18.99699, so it's very close. Okay, if you recall from skill 1, what we did to solve when x was in the exponent, we got them to be the same base. So we know that 27 is the same thing as saying 3 to the third power. Well, when you have two bases that are the same, you can go ahead and set the exponents equal to each other. So this was skill 1. So you just solve for x. You add 6, which gives you 9. You divide by 2, and x is 9/2. Okay. But what happens when you can't get them to the same base? So in number 2, 3 and 55, you cannot get them to be the same base of 3 or the same base of anything. So what we're going to have to do is we're going to convert into log form. So if you're stuck in exponential, move to log form, okay? So if you're stuck in exponential, move to log. So we have log base, the 3 is your base, of 55 equals 2x minus 6. Because again, your goal is to solve for x. And in order to do that, you're going to have to convert into log form. You also need to make sure you always put the 3 in the right spot. The 55 has to be in the right spot, and the 2x minus 6 has to be in the right spot. Otherwise, you get the wrong answers. Those 3 pieces always go in the same spots when you convert to log. Our goal is to solve for x. So in order to do that, we're going to have to get x alone. So right now, to get x alone on the right side, I would have to go ahead and add 6 to both sides. So I went ahead and I added 6, and then I'm going to have to divide by 2. So I'm going to go ahead and divide by 2 to both sides. So log base 3 of 55 plus 6. And I'm going to go ahead and divide by 2. So that's going to leave me with just an x. Okay, so you're just solving for x. And then you're done. You can type that on your calculator because we know that this value here, to type this in your calculator, we already learned you're going to type log of 55 divided by log of 3. And then you're going to hit, you can either hit enter or do this all at once, but I'm going to go ahead and I'm going to hit enter. And then I'm going to add 6, hit enter. Add 6, enter. Then divide by 2. And then enter, and that will be your final answer. So I'll show you that on the calculator after I type it in as well. So log base 55 divided by log base 3. So if we go ahead and we take a look, I just typed in the log base 55 divided by log base 3. And then the next step is going to be to add 6 to that value. I'm going to hit enter. And then I'm going to divide everything by 2. And that's going to give me 4.82 about. Now notice how I did not just add 6 and divide by 2 without hitting enter, because I have to follow order of operations. If I added 6 and divided by 2, it would have only divided 6 by 2, and I wanted to divide the whole thing by 2. So notice how I kept pressing enter between each of the steps. So we're going to go ahead and solve these again if you cannot get x, or if you cannot get them to be the same bases. So I'm going to walk you through another one. So right away, we cannot get them to be both base 2. 2 to any power does not get you 12. So what I have to do is I'm going to turn it into log form. So I'm going to say log base 2 of 12 equals x plus 1. And then to solve for x, that's my goal, I'm going to subtract 1 to both sides. You can't actually combine 1 with the 12. Those are not like terms. You have to keep those separate. So it's log base 12 minus 1 equals x, because this is connected to each other. So you cannot subtract 1 there. Okay, those are not like terms. It does not say 12 minus 1. So you're going to type this in your calculator. Make sure when you type this in your calculator, if yours opens up parentheses, you need to close the parentheses, okay? So in your calculator, that's what you're going to take a look at. If yours does not type it exactly like that, you're going to have to do log base 12 divided by log base 2, and then I would hit enter to get what that value is, and then I would subtract 1. So both of these, it depends which calculator you have. I'm going to show you my calculator here. So I've got log base 12 divided by log base 2, enter, and then I'm going to subtract 1. So notice how I did that in 2 different steps. Okay, and I'm not sure if it shows you this on your screen, my calculator, or not when I'm recording, because this is new for me to try to do, but we can talk about it in class as well. So X is about 2.58. All right, let's take a look at the next one. Again, we're going to try to go ahead and get this in log form, but the problem is we've got this 2 here. So we're going to go ahead and divide by 2 to both sides, okay? So now we have 7 to the x plus 3, and 50 divided by 2 is 25. You want to get just one base. So we just have base 7. We want to get rid of the 2, so now we can go ahead and convert. So log base 7 of 25 equals x plus 3. And then you're going to go ahead and subtract 3 from both sides. Again, you cannot actually subtract 3 from 25 because those are not like terms. The log 7 of 25 is all connected together. You cannot unconnect those. Those are stuck together, so you cannot subtract 3. And that equals x. Once again, you're going to find this value here. To find this value, you're going to do log base 25 divided by log 7. You're going to hit enter, and then you're going to go ahead and subtract 3, and that's going to tell you about what x is. So log base 25 divided by log base 7, hit enter. I'm going to subtract 3, and that gives me negative 1.35 about. All right, let's take a look at the next one. So this one just has an extra step. Again, you're trying to get this 5 to the x minus 1 by itself first. So the first thing you're going to go ahead and do is subtract 8. 24 and 8 are like terms, so it's okay for you to, 24 minus 8 is 16, subtract. Then I'm going to divide both sides by 4. And that's going to give me 5 to the x minus 1 equals 4. Okay, what I would do right now is make sure you can do this in your calculator. I would say stop. I would pause me and see if you can type that in your calculator. Try it alone. This is like a checkpoint for you to see if you're understanding what we're doing. It's not helpful to just listen. You need to actually do. Okay, so if you're tuning back, I'm going to go ahead and change this into log base 5 of 4 equals x minus 1. To solve for x, I'm going to add 1 to both sides. Again, you cannot add the 4 and the 1. They are not like terms because the 4 is connected to the log. So I'm going to go ahead and in my calculator, I'm going to type log base 4 divided by log base 5. I'm going to hit enter. Then I'm going to subtract 1, and that's going to tell me about what x is. So log base 4 divided by log base 5, hit enter, minus 1. And x is about negative 0.14. All right. So we're going to take a look at the next set of problems as well. So now we've got an E problem, which is great. Let's practice that. I'll do that with you. The first thing you're going to try to do again is isolate the e to the x. So we're going to go ahead and we're going to add 4 to both sides. Those are like terms, so that's okay to do. 36 plus 4 is 40. Then I'm going to divide both sides by 2. That's going to leave me with a 20. And now I'm going to go ahead and convert this to log form. Whoa. Since it's an E, I hope you're thinking I have to use natural log because the partner to E is natural log. So natural log base E of 20 is equal to x. So you don't have to put that e there if you don't want to, up to you, but it's automatically always there. So in your calculator, you just have to type in natural log 20 because that e is always there in your calculator as well. So natural log 20 is all I type in, and I should get 2 point, I'm going to go 0.996. It doesn't specify what to round to, so I'm going to go ahead and round to the thousandths here. Otherwise, if you rounded to the hundredths, it would actually be 3.00. All right, next one, right away, you can't get them to be the same basis, so you have to transform it to log form and then get x alone. So let's go ahead and give that a try. I'm going to do one more with you, and then I think I'm going to have you try number 8. So I'm going to go ahead and turn it into log form. So log base 10 of 1345 equals 2x minus 1. The goal is to get x alone, so I'm going to add 1 to both sides. Once again, you cannot actually add 1345 and the 1 because the 1345 is stuck with the log. Then I'm going to divide both sides by 2 to get that x alone. The entire thing by 2. So log base 10 of 1345 plus 1 divided by 2 equals x. That's my exact answer, that's called, because I didn't do any rounding. Now notice, since it's log base 10, technically all I have to type in my calculator is this. Because base 10 and log are always connected. So in your calculator, you don't have to do the change of base formula because it's 10. Any other value, you would have had to do the change of base formula. If you do the change of base formula, you're going to get the same answer. Just make sure when you do the calculator, so it's going to open up a parenthesis for you, and then it's going to close, and I would add 1, and then I would hit enter. Why am I going to hit enter? Because I want to divide the whole thing by 2. Then divide by 2. So what that's going to look like, and I'm going to show you on my calculator. Hopefully it shows you this picture. I don't actually know if it does, but if it does, let's take a look. Log 1345, close my parenthesis, plus 1. Then I'm going to hit enter. I want that entire value to be divided by 2. Oh, did I turn it off? There we go. So notice whenever I just hit divided by 2, ANS means answer. It's taking your answer and dividing it by 2. And so x is about 2.06. All right, so right now with this number 8, I would stop and I would try this alone. Okay, now you're welcome back. You might have actually done a change of base formula and tried to solve for x, but don't forget, you do know that these can be the same basis. So the easiest way to solve this one is, we know 32 is 2 to the 4, 8, 16, 32 is 2 to the 5th. So you can go back to skill 1 and set these values equal. That's the fastest way to do it. Now, could you convert to log form and solve? Yes. Would you get the same answer? Yes. So x is 4 either way, but this is definitely the fastest way. So I hope I didn't trick any of you out there, but I just want to remind you, the first goal should be to try to get them to be the same base. And if they are, it's very easy solving. A lot of times you don't need a calculator. Okay. Now we're also going to solve equations with 1 logarithm. So this is now going in the opposite direction, okay? So if you have 1 log, our goal now is going to be to isolate the log, just like we tried to isolate the part, the exponent part, to go ahead and turn it into log. We're doing the opposite, and we're turning it into exponential form. So we're going to try to isolate this by subtracting 2 to both sides. That's going to give me 4 log base 3 equals 16. And I'm going to go ahead and divide both sides by 4. So I've got log, oh, whoa, I lost my x. Hold on there. Hold on there. I did not write down part of my equation. Whoa, whoa, whoa. There we go. So 4 log base 3, I forgot my 5 minus x, there we go, equals 16. Divide both sides by 4. So we've got log base 3 of 5 minus x. 16 divided by 4 is 4. And if you're stuck in log form, because you can't do the change of base because the x is in the log, you're going to have to turn it into exponential. So whenever you're stuck in one form, try to get it to the other form. So this has a base of 3. The exponent is 4, and it equals 5 minus x. So what I did here, from here to here, you're going to go ahead and move into, if you're stuck in log, move to exponential. And the steps on the right side should say that, I believe. Yes, isolate the log, convert into exponential form, and solve. So if you're stuck in log, you have to move to exponential. Now, this is easy solving. This is algebra 1. To get x alone, I'm going to subtract 5 to both sides. So 3 to the 4th minus 5 equals negative x. And then I'm going to go ahead and divide everything by negative 1. Before I do that, I do know what 3 to the 4th is. You can use your calculator if you need to, but that's one of the numbers we should know. That's 81. It's just going to make this a little bit easier if I just start to solve here. 81 minus 5 is 76 equals negative x. Divide both sides by negative 1, and that's going to give me x is negative 76. So that's because, again, 3 to the 4th and 81 are the same thing. So it's easier just to go ahead and solve there. You could have even done it back in this step if you wanted to, put an 81 there. Okay, so the other type of problem is a little bit easier even. Notice how when we're in log form, notice that log base form and log base 4 are exactly the same here. There's a rule that says whenever the two logs are exactly the same, when there's only one log on each side, there's nothing else fancy going on. When those are going to be the same, what happens is then x is going to equal y. Okay, so that inside part of the log, sometimes it's in parentheses, sometimes not, is going to equal each other. So because of that, 2x minus 3 is equal to x. Again, this only happens if it's the same log with the same base. So pretty easy, kind of like the log base 4s drop out. So I'm going to solve this. I'm going to subtract 2x from both sides here. That gives me negative 3 is equal to negative 1x. Divide both sides by negative 1, and x is 3. Okay, so we solved all these different types. So if you see a log, sometimes you're going to have to go ahead and turn it into exponential. And sometimes you do not if there's two logs and they are the same base. So notice there is one log here and I'm stuck. So I'm going to turn it to exponential. So 5 to the 2nd power is equal to 2x minus 1. I'm going to go ahead and do 5 squared right away. So 5 squared is 25. Then I'm going to go ahead and add 1 to both sides. That gives me 26. I'm going to divide both sides by 2, and x is 13. Okay. Same thing in number 12. I notice that I just have one log. I'm stuck right now. I don't know what that is. Remember, the base with a natural log is always e. So when I convert it to exponential, it's e to the 5th power equals 3x. And then to solve for x, I'm going to divide everything by 3. So x is e to the 5th divided by 3. And the reason why I'm writing it like this, that's the exact answer. Because remember, e never ends. It's kind of like pi. But in my calculator, and hopefully this shows you my video, I don't know. So if I do second e, which is connected to the natural log here on the left side here, right here, I'll move my finger so you see it. So you do e, and we want e to the 5th power, and I'm dividing it by 3. So I type it like that. And That gives me about 49.47. So that's called the approximate answer because I've rounded it. So you should be able to do both methods. Okay, number 13, we again want to get this log part alone. That's our goal. So in order to do that, I'm going to divide both sides by 3. So that's going to give me log 2x minus 4. 9 divided by 3 is 3. If you can't do anything in log form, which we can't, you're going to convert into exponential. Remembering that the tiny little number here, because it's just a log with no base, is 10. So when you convert it, you need to know that. So it's 10 to the third power equals 2x minus 4. You should be pretty quick at converting between logs and exponential to logs. 10 to the third power is a number you should know. It's 1,000, otherwise use your calculator. Now I'm going to solve for x. I'm going to add 4 to both sides. And then I'm going to divide by 2 to both sides. I think my calculator is dying here. It's 502. Okay, almost done, guys. We're just going to do the next 3, and then we're going to stop. We're going to do the mixed practice later. So I'm going to start this one for you, and then I'm going to have you finish it. So for this one, again, you want to isolate the log in order to solve it. There's only 1. So I'm going to subtract 2 from both sides, which gives me negative log base 3 of x. Negative 4 minus 2 is negative 6. And then I still have to divide by negative 1 here so that I can get a positive log. So I've got log base 3 of x equals 6. All right, I would say stop and try to solve alone. And then check back and see if you get the right answer. Okay, so hopefully you tried this on your own. You're going to convert into exponential, which is 3 to the 6th power is equal to x. So there's not even that much to go ahead and solve there. And that's going to give you x is 729. And you're done. All right, if we take a look at number 15, notice this problem is different. Notice you have a natural log on one side and a natural log on the other side. They are exactly the same, which means when we go ahead and we solve here, you can go ahead and say 4 minus 2x equals 3x minus 11. This is actually pretty easy. So it's just 4 minus 2x equals 3x minus 11. So I'm going to go ahead and add 2x to both sides. So I have 4 equals 5x minus 11. I'm going to add 11 to both sides. That gives me 15 equals 5x. Divide both sides by 5, and x is equal to 3. Okay, so I'm going to say stop. And I'm going to say try number 16 alone, and then unpause me and see if you got the right answer. Go. All right, so for you guys that have solved it, notice again, they're both log base 3, which means you can set the x equal to the 2x minus 5. So we've got x equals 2x minus 5. So I'm going to go ahead and subtract 2x from both sides. That gives me negative 1x equals negative 5. Divide both sides by negative 1, and x is positive 5. So we've learned 3 different things really today. The first type of problem is if it's given to you an exponential and you cannot get them to the same base, you're going to convert into log form. And then you're going to have to use a calculator to actually get the answer. The other one is if you see logs and you can't solve the log, you're going to convert into exponential form at some point once you isolate it. And then finally, the last type of problem is if the logs have the same bases and there's 2 of them, 2, 2, 2, notice 2 of them, then you can set the inside part, the x equal to the y. We will learn how to solve them when they are different bases, but we're learning that in college algebra. So this topic is an Algebra 2 topic, because again, we're going over the things that you guys missed from quarter 4 last year. So we will learn more about this in college algebra. So these are kind of the prerequisite things that you should know already. So I'm going to go ahead and stop there. And on a separate video, I will do the mixed practice. Otherwise, I would say you can try the mixed practice on your own. And then if you need that help and you need to check your answers, I would go ahead and listen to the video as I walk you through all the different types of problems from skills 1 through 3. All right, thanks for listening, guys.